So what you want to do is you want to ask the question, what effect does applying a diagonal matrix to a vector have? Well, what this answer here summarizes is the fact that if you take this diagonal matrix, and I'm not going to write the zeros, and you apply it to a vector, then we saw when we defined diagonal matrices that the first component is multiplied by this element of the diagonal matrix, a second component by this, and a third component by that. So the question then is, how do you undo that? Well, you undo that by multiplying the first component by -1, the second component by 1/2, and the third component by 3. But that happens when you pick a diagonal matrix that has as its diagonal elements -1, 1/2, 3, and the rest zeros. Compare this to this. What is going on? Writing this out, how do you undo this? Well, you multiply the first component by -1/2, -1, etc. So we conclude that the inverse of a diagonal matrix with elements -1, 2, 1/3 is a diagonal matrix with elements -1, 1/2, 3. Perhaps there's a pattern there. And then you can check, multiply all of this out, and you see that indeed you get the identity matrix back. Okay, in the next homework exercise you were asked to generalize this. The pattern that you hopefully saw was that all you do is replace the diagonal elements with their inverses. Okay, that's what this here says. Indeed, that's always the case, and that's just a matter of multiplying it out. Okay, let's move on and go to a slightly more complex matrix. This matrix here you should recognize as a Gauss transform. So go and do the homework, and I'll see you in the next video.